So at the 20th annual Needham conference, we have Rigetti CEO Dr. Kulkarni, who has joined and provided some insight into Rigetti and the business operations and the outlook. They talk about many different concepts like the technology that they're working on, specific insights into the commercialization, investor and investor relations, the quantum benchmarking initiative, and a bunch of other things, including their investment with Quanta investing in Rigetti, not only their $35 million initial investment, but an additional $250 million over the next 5 years. So we're going into Rigetti earnings next week, and the video is pretty long. So I'm just going to show you all. I watched the whole thing, but I'm going to show you just the segments that I think are the most important to earnings and the most important to the company at this time. I've also taken notes, so I'm going to share those with you. Let's jump right in. We are going to jump right in. I have picked a couple parts where I'm going to do a little bit of react, and then we're just going to read through my notes and I'm going to explain what was discussed in the call. So the overarching sentiment from this call is that Rigetti is still an R&D company. They're still in the research phase. They think they're a couple years away from useful commercial applications.
And what is this? So gate-based quantum computing, which is what we do and many other companies do, is basically very similar to non-gate approaches because let me first talk about gate versus.
So in this segment of the video, Dr. Kulkarni is going to talk about D-Wave, and I think let's roll the tape and then let's talk about it.
Is non-gate approaches because there's a lot of confusion for investors who are new to understand what is this. So gate-based quantum computing, which is what we do and many other companies do, is basically very similar to classical computing. We create gates out of these qubits and then we use these gates to do the computation, just like your classical computers do. There are some, because quantum is a unique property, there are some companies that are taking advantage of unique quantum properties and creating computers with that, such as Annealing. There's a company called D-Wave that does that, or Entropy. There's a company called Quantum Computing. Even though the name says quantum computing, they're doing Entropy. And they're fundamentally very different than quantum computing. They are taking advantages of some unique quantum states, and that helps them solve some specific applications. But in general, our view is that gate-based is going to be the dominant part of quantum computing. Most of the applications are going to be using gate-based quantum computing. There will always be some unique applications that may be suitable for annealing or entropy, but those are going to be niche kind of areas. So I'll focus on gate-based from here on.
Okay. So you have someone, a CEO of a company who is essentially making a comment or about a competitor, and D-Wave with their annealing quantum computing are currently commercially viable and currently making money. In a recent Opto interview where Dr. Baratz went on and talked to Opto, he explained that there was a time when quantum computers were thought to, the holy grail was gate-based, and that annealing was more or less how he's painting it here. Niche, not really that useful except in very little use cases. But when you actually talk to D-Wave and you hear D-Wave's customers talk, the sense that there is actually a lot of commercial application for the technology.
Approaches to quantum computing. One is called quantum annealing, as you just mentioned, and D-Wave is actually the only company in the world that provides annealing quantum computers. Everybody else is focused on gate model quantum computing. Now, there are some important differences between the two. Perhaps one of the most important differences is that annealing is a much easier technology to work with. It's easier to scale, and it's much less sensitive to errors. And as a result, our quantum computers are an order of magnitude larger than any other quantum computer, and they are able to deliver good, if not optimal, solutions to hard computational problems today without the need for error correction. Okay, So we decided to start with annealing. 8 or 9 years ago, when everybody else decided to seriously pursue developing a quantum computer, the science and the engineering had progressed to the point where it was believed you probably could build a gate model system. And at that time, and this is a really important point, at that time, it was believed that a gate model quantum computer could perform all computations, could basically solve all types of problems better than classical. And so everybody else sort of adopted the point of view, well, we know that annealing is good at some things, but not all things. We believe gate model is good at all things. We now think we know how to build a gate model system, so let's go there. Now, fast forward to a couple of years ago, and this is a really kind of interesting twist of fate, at least for D-Wave. A couple of years ago, it was proven by researchers in both the US and Europe that gate model quantum computers will likely never deliver a speed up on optimization problems. That you basically need an annealing system in order to address optimization problems. So now it's not that one is more general than the other. It's not that at all. It's that there are some applications that will always run best on annealing, and there are other applications that will always run best on gate. So you're always going to need both.
And I thought it was interesting also that Dr. Baratz had mentioned that annealing and gate-based will be used in tandem together. So there seems to be a little bit of a disconnect of how Dr. Kulkarni views D-Wave and how Dr. Baratz views D-Wave. But I thought that was interesting. And it's interesting when you see CEOs kind of talk about each other's companies. Let's take a look at my notes here. So like I said, I'm trying to save you all time. So I wrote down my notes as we went through this longer video. So their key targets are scalability and gate speed. These are paraphrase quotes, but what has changed in the last few months at Google, Amazon, Rigetti, we're all in the 99 to 99.5% fidelity, which is critical. So their Anka 3 system has a 99.5% fidelity. Dr. Kulkarni said we need to get to 99.8 or 99.9% fidelity to have commercial viability. Dr. Kulkarni reinforced the open modular concept, and he drew some comparisons to Amazon, who's building a mainframe computer that's a closed computer, their Ocelot mainframe quantum computer. By contrast, Rigetti is building a quantum computer and the components in a modular way, which creates the ability for Rigetti to scale and pivot and change as the quantum landscape evolves. Dr. Kulkarni also mentioned the need for chiplets and tying chiplets together on a board, on a computer processing board. And he didn't see a way to cram 100,000 qubits on one chip. He thinks that using chiplets and having them in an array is going to be the best path forward. The good thing is that they're building on 10 to 15 years of CMOS and semiconductor research. So they're not starting from scratch, which is great and often overlooked in the quantum computer conversation. We're already building on decades of computer knowledge and computer fabrication knowledge. So far, fidelity has been a limiting factor. So it was pretty clear to me that Dr. Kulkarni sees the first hurdle as fidelity. And when fidelity becomes better, error correction will be the logical next step. Rigetti wants to show fast gates and real-time error correction codes, moving from coax to flex cables. Now we're going to go back into the video because I thought it got really good towards the end, where there's some questions about DARPA's quantum benchmarking initiative, the Quanta investments, and the Quantum Reauthorization Act. So let's take a look. It starts at 28 minutes here.
All of the information about that program is available publicly, so you can just go and do a search on the internet to get access to the information. So the openly stated goal is that DARPA wants us to build a what they call utility scale quantum computer, which would basically we have used the word fault tolerant quantum computing before, but kind of similar to that. So essentially you can do any practical application significantly faster and better than what your conventional computing can do. That's the goal. Timeline is 2033. It's a man on the moon, moonshot type of an initiative. They really are pushing all of us, saying, how will you get us there? And frankly, that timeline is far faster than what we were internally contemplating, because we are to get to what they are asking us to do. We are talking several 100,000 physical qubits. That's what you are going to need. You are going to need 99.9% 2-qubit gate fidelity or better. You are going to need faster than 10 nanosecond gate speeds. And you are absolutely going to need real-time QLDPC type error correction code. So 4 things again. So you need probably more than 100,000 physical keywords. You need 99.9% or better fidelity, faster than 10 nanosecond gate speeds, and real-time QLDPC type codes. Assuming you can get those 4 critical things, and there's probably 100 other things that I'm not going into right now, but assuming you can get those 4 high-level things, you will be able to demonstrate a utility scale quantum computer. And that's what we propose. That's what we will do. Challenging task, exciting project. We are proud to be part of the initial 15 companies that they have chosen. We understand probably 100 or so companies applied for that. And in a way, it kind of helps everyone understand who's where right now. So we are proud to be part of that group of 15 that got chosen for phase A. In 6 months, roughly, there's going to be a phase B decision, and that's a very important decision. Obviously, we want to be part of the go forward group. My guess is they will probably reduce the number by a factor of 2 or factor of 3. So you're talking about 5 to 7 companies at that point. Our goal, we know we need to demonstrate what we have already publicly stated. We want to demonstrate the multi-chip architecture, the chiplet architecture. We want to continue to show higher fidelity, faster gate speeds. That's what we want to show. Right now, for phase B, error correction is not that important because we are still dealing with physical hardware situations. But then about a year from now is phase C, which is where you are going to be dealing with 1 or 2 companies. And that's where the award becomes substantial. It's going to be in the hundreds of millions of dollars at that point. They haven't disclosed the final number because in a way they want to keep it open too, depending on how many companies and what exactly is being discussed.
That's a pretty large award. And any company that gets that award is going to see their private or public investment skyrocket in proxy. So the QBI is very important for who is to advance to the next level, not only from a monetary standpoint, but also the optics of, okay, you're in first, second, or third place. You're in first place in this race, and we're going to pull out our wallets and give you more money. So not only is it going to be the money that's coming from DARPA directly, but it's going to be all the private and public investment as well.
But it's going to be a substantial award for the final 1 or 2 companies that are going to win it. We are talking hundreds of millions of dollars. But that's really where we want to be, and that's where we definitely need to get to our milestones that we have publicly disclosed by the end of this year, and continue to improve on fidelity and qubit count and gate speeds to get to that milestone. So it's an exciting milestone. We are really proud to be part of this project, and that's certainly driving our roadmap right now.
Yeah, no, it's a definitely an exciting project, fun to watch, and it'll be very interesting as we move into the fall to sort of see who's selected to move on to phase B. So good luck with that, and we'll certainly be watching. Another customer announcement. This one definitely with an air towards commercialization of quantum computing is your collaboration and strategic investment by Quanta Computer in Taiwan. Obviously, many investors, I'm sure, know Quanta Computer, a very big player in the computing world. And so spend a minute just sort of discussing your collaboration, what both companies have committed to as part of this collaboration in terms of funding and developing quantum technologies, and just touch on the investment which was also part of that announcement.
So Quanta Computer, based in Taiwan, is well known. I mean, they are a big time ODM player in the computing world. About last year, they were about $43 billion sales, and growing very rapidly. One of the main drivers of their growth right now is GPU servers. They are a very, very close partner of NVIDIA. So as many of us know, NVIDIA designs the chips, TSMC builds the chips, and usually companies like Quanta take over at that point and build the rest of the hardware around it. And they are the ones who are physically selling those systems to the cloud providers, the hyperscalers, Amazon, Microsoft, and so on. So that's the way the current GPU ecosystem works. Quantum Computer on their own fully understood that quantum computing is the next big thing after GPU, and they have been looking at where to invest. Our understanding is they concluded that superconducting gate-based is the right area to invest, just like many of us and along with big other large companies. And then within that, they talked to many companies that are in the superconducting gate-based camp. They looked at where we are, what our roadmap is, and chose us. So we are really proud to be chosen by, to some extent, Quanta Computer. From our side, we knew that long term we needed an ODM player. It doesn't make sense to build CPU, GPU, FPGA boxes in Berkeley, California, which is where I am. That's not exactly your high volume, low cost manufacturing location by any means. So long term, we knew that we needed to choose the right ODM player to partner with in this area as the volumes increase and we go commercial. Frankly, we were a little surprised that an ODM player of the size of Quanta would be interested in quantum computing at this earlier stage, because we are still talking about R&D right now. And historically, ODMs don't dabble that much in R&D. Quanta is an exception among the ODM players. If you go back to their history, they were one of the first ones to invest early in laptops, which is what enabled most of the MacBooks from Apple right now come from Quanta. That's public info. And one of the reasons they are NVIDIA's biggest partner is because they were one of the earliest ones to invest in GPU technology. So their philosophy of being relatively early among all the ODMs is continuing there.
So this is huge. This is a huge investment, not only in the money, the $35 million investment is nice, but look at the track record of Quanta. They're a massive multi-billion-dollar company. They build laptops for Apple. They have placed early bets on key players, and they've been right in the past. So very interesting. And they're also a big partner of NVIDIA, which is one of the biggest tech companies in the world.
Being relatively early from the ODM side to invest in quantum computing, we are really happy to partner with them. Our cultures in that sense match. We both think of the business as a long term. So anyway, it's a long term strategic partnership. One part of it was they essentially gave us $35 million to get about 3 million shares. So it came to about $11.59. That's a token investment. That's typically the way large Asian companies work. They want to show that they are part owner of the company, and that's great. But the more important part is they committed to investing $250 million over the next 5 years in the non-quantum portion of the hardware stack. So if you look at a quantum computer, there is a chip, there is what we call a QPU unit, then there's the rest of the hardware, which is quite a lot. There's a dilution refrigerator, there's all these cables that we talked about earlier. Then there's several layers of firmware and software on top of it. So it's quite a bit of investment needed in each of these layers of the stack. And certainly on our own, we were doing everything all these years. But as the business starts increasing in size, it makes sense to focus on what you're really good at. And clearly what we are really good at is the chip design, the chip fabrication, and the immediate layer of the hardware and software that comes after that. Then when it gets to the bigger complex racks and CPUs, GPUs, FPGA systems, ASIC systems, that's really not Rigetti's strength by any means. It doesn't make sense for us to keep doing all that work. So we view it as a very favorable. Essentially, their investment helps us reduce our R&D investments in future. So we view it as a very strong ODM partner that is committing $250 million besides that additional $35 million that they gave us.
I didn't know about the $250 million. So for these small quantum companies that are in the R&D phase at this current point in time, that's a significant monetary contribution beyond this initial $35 million. And this strategic partnership between the two makes a lot of sense for both sides. And you can hear Dr. Kulkarni is very ecstatic that this is happening for Rigetti, and it does seem to be extremely favorable for Rigetti going forward.
So very strong partnership. It is a long-term strategic partnership. We both of us view this as a solid 20, 30-year kind of a partnership, just like what they have done with NVIDIA in the GPU world and with Apple in the MacBook world.
Perfect. We've got about 5 minutes left. Wanted to sort of switch. I know, some of the questions we've gotten around quantum computing is and certainly Rigetti is in the development stage of developing the technology. U.S. government and allied government funding is important. And so maybe just, can you give us any updates, sort of that you see right now? I know there's sort of the reauthorization of the National Quantum Computing Act that's still in Congress. Can you give us any updates on the status of that? And I guess related questions we've seen from investors are, the Department of Government Efficiency has been making a lot of cuts in the government. Have you seen any quantum programs fall victim to DOGE? And I guess, maybe tangentially, lots of focus on the government right now on tariffs. Has tariff talk kind of distracted the government from, some of these other initiatives? I know that was a handful.
Yeah, but so let me take the tariff one first. I mean, we are in R&D. Fundamentally, most of our cost is R&D cost. We are not buying a lot of components, and we are not selling a lot of finished systems. So tariffs are relatively insignificant in the big picture. Of course, we watch it. It's still a contributor to our cost, but it's not a big deal. The other question, which is more important, is the government funding. NQI reauthorization is absolutely critical for companies like Rigetti long term. And as of today, that hasn't happened yet. There's bipartisan support, as you probably have heard from us and other companies. The original bill should have been signed last summer, actually. Didn't happen. Obviously, a new admin has come in. There's still bipartisan support. Literally, there was a hearing in the House just a couple of days ago, and I could see the transcripts. I wasn't there, but I could see the transcripts. And there's continued bipartisan support. All indications are, even Trump has made a few statements saying that he supports quantum computing. So we don't expect major glitches, but it hasn't happened yet. And that's a critical piece of legislation that we need not only to get passed, but appropriated, because it's a $2.5 or $2.7 billion bill over 5 years. So almost $500 million or so. So that we are eagerly awaiting signage of that bill and appropriations of that. DoD funding has started, as you can clearly see from the DARPA contract. And then another award we announced is with the Air Force Research Lab for one part of our stack, which is that ABAA technology. So we'll continue to get more and more of those kinds of things. But we certainly are eagerly awaiting for the bigger thing to get released. I'm sure many other companies are waiting for that as well. But our focus is definitely on technology. In the meantime, our financial situation has improved a lot because of the money we have been able to raise, as well as Quanta Computer helping us out on that front. So we feel pretty fortunate that we are in a very good position financially right now to stay focused on technology milestones. And hopefully the US government funding will resuscitate quickly.
Okay, so quick recap. Dr. Kulkarni, if you're investing in Rigetti, you have the luxury of knowing exactly where the company is, and the bar is so low on earnings and expectations that when you put your dollar into the company, you're investing in the future. You either agree with the approach that Dr. Kulkarni and his company are taking, or you don't. But there's no question of is this commercially viable tomorrow? And I think with this interview, it's very clear that the Rigetti and their team is focusing on the branding at this point in time as a R&D company, a company that needs these contracts to be financially healthy. But with their good fortune with Quanta, they are financially healthy even without the contract. So that's why it's so important that these bills that are sitting in Congress with bipartisan support get passed, so that companies like Rigetti can accelerate their research and accelerate to a gate-based quantum computer that can be built at utility scale, that is viable commercially. So it's also a stark contrast as well. When you look at Rigetti and D-Wave, D-Wave has really leaned into their marketing and the commercial viability today and the commercial adoption. And we have many different companies with many different approaches in this quantum space. And that alone is super interesting. We are blessed with different options. Let's see what his closing thoughts are.
Well, yeah, hopefully it'll get signed. I know we're sort of up against the end of the session, but Subodh, I just wanted to give you the opportunity if there was any. There are no questions from the audience. So, were there any last minute thoughts or any important points I didn't ask about that you'd like to share with the audience?
Just that fundamentally we are super excited about this area, the potential for this. However, we believe we are very much in the R&D stage right now. We believe it's what is critical is technology milestones right now, and getting to that. That's how we solve complex challenges and enable large business opportunities. So again, thank you for your interest and all the questions.
I mean, as a Rigetti investor myself, I love the transparency. I love the honesty, and I love the Quanta partnership, the key milestones, and I thought Dr. Kulkarni navigated this interview really well. What did you guys think? Did you think that this interview made you feel better about your investments in Rigetti? What do you think about upcoming earnings for Rigetti? Do you think they're going to miss, or do you think there's going to be a surprise? What do you think about the future of the company? Is there anything else that you took from this interview that has changed your opinion of Rigetti or quantum computing in general? Let me know in the comments below, and hope you have a good day.